Hey, what's up, everybody? In today's lesson, we're going to go over the addition and multiplication properties of equality. So here we have 2x plus 1 equals 7, and it tells us to find the solution. Now, given an equation like this one, what we mean when we talk about the solution of x is the value of x that's going to make the left-hand side equal to the right-hand side, therefore giving us a true equation. So I've gone ahead and solved this beforehand, and x equals 3. Now, notice what happens when we plug in 3 for x. Okay, so 2 times 3 is 6. 6 plus 1 is 7. So on the left-hand side, we have 7. And on the right-hand side, we have 7. 7 equals 7. Therefore, this equation is true. So the reason why we're learning the addition and multiplication properties of equality is that knowing these properties allows us to solve for x, the unknown value in the equation. So here are the steps to solving an equation. The first thing you need to know is that the goal of solving an equation is to isolate x, meaning we want x by itself, okay? So at the very end of the process of solving an equation, what we get is x equals some number. Okay. And the second thing you need to know about solving an equation is that the method, in other words, how we isolate x, is going to involve something called inverse operations. Okay. This means do the opposite of whatever is being done to the x. Okay. So just to clarify, inverse operations basically means do the opposite of whatever is being done to the x. So if we're adding something like 5 to x, the inverse operation of that, the opposite of that, would be subtracting 5 from x. Okay? If we instead were multiplying x by 5, the opposite of that, in other words, the inverse operation of this, would be x divided by 5. Okay? So in order to actually do these inverse operations, you need to know about the properties of equality, okay? The first property of equality that you need to know is the addition property of equality, which says that whenever you add or subtract a number from one side of the equation, you also have to do it to the other side of the equation as well, okay? The reason why we do this is to maintain the equality of the equation, okay? In other words, we want to keep the left-hand side equal to the right-hand side. So here we have x plus 7 equals 9, and we know that x equals 2, okay? We know x equals 2 because, well, 7 plus 2 gives us 9. But let's try changing the equation by adding 3 to both sides, okay? We're going to try to change it. So we're going to add 3 to both sides. And when we do that, we get x, okay? Nothing is being added to x itself. And then we have 7 plus 3, which is 10, positive 10, on the left-hand side. And on the right-hand side, we have 9 plus 3. And 9 plus 3 is going to be what? 12. And let's try plugging in 2 for x. We get 2 plus 10 equals 12. And we know that 2 plus 10 is 12. Therefore, 12 equals 12. And therefore, we have a true equation. Now, what happens if we only add 3 to one side? What do you think happens then? So instead of adding 3 to both sides, let's try adding 3 to the left side only. So what happens is we get x plus 10 equals 9. And if we plug in our known value of x, which is 2, what happens is we get 12 on the left-hand side and 9 on the right-hand side. And this is false. 12 does not equal 9. Therefore, this is a false equation. Okay, and that's what the addition property of equality basically boils down to. Okay, it says whatever you add or subtract from one side of the equation, you must also do to the other side of the equation. Do the exact same thing to the other side. okay, to keep the equation true. The second property you need to be aware of when you're doing these inverse operations is the multiplication property of equality. The multiplication property of equality just tells us whenever we multiply or divide one side of the equation by a number, we need to do the exact same thing to the other side. Okay, so if we multiply by 3, then we need to do the exact same thing, multiply by 3 on the other side of the equation. So to show you the exact same idea, here we have the exact same equation from the previous example. We have x plus 7 equals 9, and we know that x equals 2. Let's go ahead and try and multiply both sides of this equation by 3 and see what happens. So here we can use the distributive property to simply multiply the x and the 7 by 3, okay? Just know that you can't, x is a variable and 7 is an integer, it's a number, so you can't actually add those two, okay? But we can use the distributive property to multiply x plus 7 by 3. So when we do that, we get 3x plus 21 equals 3 times 9 is 27. Okay, so this is what we get. Let's try plugging in this known value of x, 2. Okay, so we're going to plug in 2. So we end up with 3 times 2 equals 21. And then 27 on the right-hand side. 3 times 2 is 6. 6 plus 21 is 27. So on the left-hand side, we end up with 27. And on the right-hand side, we have 27. Therefore, this is a true equation. What do you think happens if we were to only multiply one side by 3? So we're just going to multiply one side, so the left-hand side, and we're going to leave the right-hand side as it is. Well, what happens is, again, we multiply 3 by x and the 7 using the distributive property. So we get 3x plus 21 equals 9. And let's try plugging in our known value. Okay, so x equals 2. And when we do that, we get 3 times 2 equals 21. 3 times 2 is 6. 6 plus 21 is 27. Okay, so on the left-hand side, we get 27. And on the right-hand side, we get 9. Therefore, this is false. 27 does not equals 9. Okay, so the idea of the multiplication property of equality is that whatever you multiply or divide on one side of the equation, you must do the exact same thing on the other side of the equation to keep the equation, to maintain the equation as true, okay? So here, let's actually go over solving an equation. And if you remember from earlier, just a minute ago, we said this, okay? I gave you the steps to solving an equation, which says that the goal is to isolate x using inverse operations. Isolate x using inverse operations. What that means is it's just a fancy way of saying get x by itself. Okay, get x by itself by doing the opposite of whatever is done, whatever is being done to the x. Okay? Isolate x by doing inverse operations means get x by itself by doing the opposite of whatever is being done to x. Okay? It's as simple as that. So, okay. So, what is happening here? Well, as you can see, we're subtracting 3 from x. So what would be the opposite of that? The opposite of that would be to add x, right? We have, if we're taking away 3, then the exact opposite of that would be to add 3, okay? So that's what we're going to do. We're going to add 3, but because of the property of addition, okay, the addition property of equality, we're going to add 3 to both sides. Okay, and when we do that, what happens is the negative 3 and the positive 3 cancel each other out. okay? On the number line, if you start at -3 and you go right 3 steps, you end up at 0, okay? -3 and +3 cancel each other out. They become 0. So you can just cross it out, and what you're left with is, on the left-hand side, you're just left with x by itself, okay? And on the right-hand side, 12 plus 3 is what? It's 15, okay? Our answer is 15. And the great thing about this is that you can check your answer to see if you did it correctly by simply plugging in your answer into the original equation. Okay, so let's do that. 15, so our original equation, we simply replace the x with 15, and then -3 equals 12. Well, 12 minus 3 is what? It's 12. Therefore, because 12 equals 12, we know that this equation is true, and our answer is indeed 15. Okay? Let's try another example. Okay, so here we have x plus 7 equals -12. Just like before, the goal of solving an equation is going to be to get x by itself on its own. Okay, so we want x by itself on its own, and it's going to equal something. We don't know that yet, but we're going to figure it out. And we do that by doing the inverse operations that we learned about. Okay, in other words, do the opposite of whatever is being done to x. So here you have +7. We're adding 7 to x. The exact opposite of that would be to subtract 7, right? And the addition property of equality tells us that we have to do it to both sides. So that's what we're going to do. We're going to subtract 7 from both sides. And +7 and -7 are going to cancel each other out, right? Two numbers with opposite signs. This one is positive and this one is negative. If you have two of the same numbers and they have opposite signs, they cancel each other out and become 0, right? On the number line, if you start at 0, go 1, 2, 3, 4, 5, 6, 7 steps to the right, okay? If you go 7 steps to the right and then 7 steps back to the left because of the -7, you end up at 0, okay? So these will cancel out. And on your left-hand side, you're going to be left with x, which is exactly what we want. And on the right-hand side, we have -12 and -7, okay? Since they have the same sign, negative and negative, what you're going to do is you're going to add them, and our answer is going to take the sign of negative, okay? If you were to consider the number line, what's happening is you're taking 12 steps in the negative direction, and then you're taking 7 more steps in the negative direction again. So 12 plus 7 is 19, but because they're both negative, it's going to be a -19. Okay? And again, the great thing about math is you can check, or at least algebra, you can check if your answer is correct or not. And once again, we do that by plugging in our answer into the original equation. Okay, so if I do -19 plus 7, on the right side we have -12. -19 and +7 is -12, okay? So -12 equals 12, therefore, this is a true equation, and this is the correct solution. Okay? Let's try another example. And once again, if you really want to learn this subject, I highly urge you to pause the video and try this on your own. I'm going to give you a couple seconds. Okay. So once again, we want x by itself. We want it to equal something. We don't know that yet. So what's happening is we're multiplying x by 3. Okay? Now, if you remember, we have to do the opposite of what's happening. So what is the opposite of multiplying? The opposite of multiplying is dividing, right? So if we're multiplying by 3, to get rid of this 3, to get x by itself, we would have to divide by 3. And we would have to do it to both sides because that's what the multiplication property of equality tells us, right? We want to maintain equality. We need the left-hand side always equal to the right-hand side. So when we divide 3x by 3, what happens is the 3's cancel out, and what you get is x, just x by itself. Okay, now if you don't understand what's happening here, what's happening is this is 3 over 3 times x over 1. Okay, these cancel out. 3 over 3 is just 1. So what you're going to end up with is x over 1, which is x, right? So that's why we have x. Anytime you get a situation like this, right, where you have a coefficient and a variable, and you're dividing by the exact same coefficient, the coefficients cancel out, and you're just left with the x. Okay, so we have x on the left-hand side, and on the right-hand side, we get 9 minus 9 divided by 3, which is 3. And 3 is our answer. And for this one, I'm going to leave you to actually check our answer. Okay, so all you have to do is plug in your solution back into the original equation, and if the left-hand side equals the right-hand side, in other words, 3x, if 3 times 3 equals 9, then you know your answer is correct. Okay, let's move on. So here we have something a little different. Okay, here we have 2x plus 3 equals 10. And once again, I urge you to pause the video and try this on your own. I'm going to give you a couple seconds. Okay, so here, again, we want x by itself. But right here, two things are being done to x instead of just one. So first thing that's happening is x is multiplying. X is being multiplied by 2, okay? And the second thing that's happening is that x is being divided by 3. Okay, so the strategy is always going to be the same. You always want to get x by itself by doing inverse operations, by simply doing the opposite of what's being done to x. So all you have to do is do the opposite of that, and then do the opposite of that, which should isolate x. Okay, so the opposite of dividing by 3 is multiplying by 3. So let's go ahead and multiply both sides by 3. Okay, so on the left-hand side, the 3's cancel, and what you're going to be left with is just 2x. So if you don't see what I'm talking about, what's happening is this is the same thing as 3 over 1 times 2x over 1. Sorry. Yeah, so 3 over 1 times 2x over 3, okay? 3 over 1 times 2x over 3. And if you know anything about multiplying fractions, you should know that the 3's cancel, right? 3 goes into 3, so they just simply become 1s. And 1 times 2x is just 2x, and 1 times 1, okay, is just 1, and 2x over 1 is 2x, okay? So that's what's happening on the left-hand side. The 3's cancel out, and you just get 2x. And on the right-hand side, you get 3 times 10, which is 30, okay? Now we have to do the other part, which is the opposite of x being multiplied by 2. So the opposite of x being multiplied by 2 is to divide by 2, right? So let's go ahead and do that. We're going to divide by 2 on both sides. Okay. Once again, you have 2x over 2. These cancel out. Okay. It's just 1. So therefore, what you're left with is just x. Okay. So we have x equals 30 divided by 2 is actually 15. But if you want to actually do the division, well, 2 goes into 3 one time. 3 minus 2 is 1. 0 comes down, so we have 10 divided by 2. 2 goes into 10 5 times, and 10 minus 10 equals 0. No remainder, x equals 15. Okay, so x equals 15 is our answer. And once more, I'm going to challenge you to check the answer to see if we did this correctly by plugging in your answer into the original equation. Now, one thing you need to know about this exact problem is that there's different ways of being presented of the problem. So the original problem is 2x over 3 equals 10. But in your textbooks and in your homework and in class, this might be presented as 2 over 3 times x equals 10. Okay, what you need to realize is that these two expressions, 2x over 3 and 2/3 times 3, are exactly the same. Okay, these are just two different ways of writing the exact same expression. Okay, let's go over one last example. Here we have 7x minus 5x equals 12. And once again, I urge you to pause the video and actually try the problem on your own. All right, I'm going to give you a couple seconds. Okay, so with this problem, you should realize, if you remember our first lesson on variables for this Algebra 1 series, you should know that we have like terms here, okay? They have the same variable, same exponent. There's, right, 7x is the same thing as 7x to the first power, okay? And 5x is the same thing as 5x to the first power. So these are like terms, and that means you can actually subtract these two, as if you were actually doing 7 minus 5, okay? So 7 minus 5 is what? It's 2. And all we have to do is add our variable. So 7x minus 5x is 2x, okay? So this is the same thing as 2x equals 12. And now the problem is actually easier, okay? So what's happening is 2 is multiplying x, and so we would have to do the inverse operation of that, right? We want, again, going back to the original steps to solving an equation, you want x equals something, and we do that by inverse operations. The opposite of multiplying by 2 is dividing by 2, so we're going to do that for both sides. Okay, and when we do that, the 2's cancel out. What we get is x on the left-hand side. Once again, if you don't know what's happening, this is the same thing as 2 times 2 over x minus 1. 2 over 2 is 1. They cancel out. And x over 1 is the same thing as x. Okay, that's why we have this x on the left-hand side here. And on the right-hand side, all you have to do is divide 12 by 2. Okay, dividing 12 by 2, you get 6. And that should be our answer. And once again, I leave it up to you to check to see if we did this correctly by plugging it into the original equation. Another recommendation that I make is, if you look at my videos, so here is the Algebra 1 series that I'm working on. This is the video on equations. If you look at the videos in the description, there are links to practice problems, okay? If you click on the link, it'll take you to a Google form where you can actually practice what you've just learned on Google Forms. And if you put your email address in, what it'll do is send you the results of this assignment or these practice problems. Okay, so I highly urge you, if you actually want to learn what you want to learn, especially math, there's only one way to do it, and that's learning by doing. So I highly urge you to actually practice what you learn on these problems or other problems wherever you find them. Okay, thank you for watching, and I'll see you next time.